Welcome back, everybody, for another deep dive. This time, we're going all the way to Singapore
Singapore.
to look at a really cool training program
Okay.
for physics teachers
Interesting.
who are learning how to teach gravity in a very unique way.
Oh, wow.
We'll get to it, but there's even a connection to Angry Birds.
Angry Birds. The game. I'm intrigued. How do those two things connect?
Well, the program uses a tool
Okay.
called Easy Java Simulations, or EJS,
Okay.
to create interactive models
Huh.
that can help students understand gravity.
Mm-hmm.
It's actually free,
Oh, wow.
and it's open source.
So teachers can get creative with it.
Exactly. They can customize the simulations.
Yeah.
They can even build their own simulations.
That's really cool. So it's like a hands-on approach to gravity instead of just like a lecture.
Exactly. And research even shows that active learning like this actually leads to
Yeah.
deeper understanding and better retention
Oh, I believe that.
than passive learning like a lecture. This training program, though, didn't just throw the teachers in the deep end with this tool.
Yeah.
They actually provided them with a bunch of resources,
Okay, good.
including access to libraries
Okay.
with like hundreds of pre-made simulations.
Wow.
And even one of the libraries
Yeah.
was created by the trainer himself.
Oh, that's awesome.
I know. So really cool to get them familiar
Yeah.
with EJS.
Absolutely. See the potential.
Yeah, and kind of get the hang of it before
Yeah.
they have to build their own.
Yeah, that makes a lot of sense. So what kind of gravity concepts were they looking at specifically?
Well, they focused on 4 key simulations.
Okay.
One was a geostationary orbit model.
Mm-hmm.
Another one was a 2-mass model.
Okay.
And then there was an Earth-Moon model
Got it.
and a Kepler's third law system model.
So lots of different aspects of gravity. Could we maybe break down one or two of those? Like, for people who haven't thought about physics in a while, what exactly is a geostationary orbit?
Oh, yeah. So a geostationary orbit, it basically means that the satellite stays above the same spot on Earth at all times.
Oh.
So like think about communication satellites
Yeah.
that beam TV signals.
Yeah. Okay.
They need to stay in a fixed position relative to a specific location on the ground.
That makes sense.
That's what a geostationary orbit is.
Gotcha. How about the Earth-Moon one? I've always found escape velocity a little tricky to wrap my head around.
Yeah, escape velocity is definitely a tricky concept.
It is.
So escape velocity is the speed that an object
Okay.
needs to reach to break free from a planet's gravitational pull.
Mm.
And with the Earth-Moon model, students can adjust different variables,
Mm.
like the initial velocity of an object launched from Earth,
Okay.
and then they can observe and see if it escapes the Earth's gravity
Oh,
or
cool.
if it gets pulled back down.
Oh, so they can really experiment with it. That's a lot more hands-on than just like, reading it in a textbook.
Exactly.
Yeah.
But the training wasn't just about using the simulations.
So-
They also focused on a new approach to lesson planning called the 5E instructional strategy.
5E instructional strategy.
Yeah, and this is all about engaging students,
Okay.
encouraging them to explore concepts
Yeah.
through hands-on activities,
Mm-hmm.
and then guiding them to explain their findings.
So it's really student-centered.
Very much so.
Yeah, that makes sense. Is that where the Angry Birds connection comes in?
Yeah, so it's not that they were using Angry Birds in the classroom,
Oh, okay.
but the idea is that the game itself
Yeah.
sort of involves similar physics principles to the simulations.
Oh.
When students are playing Angry Birds,
Mm-hmm.
they're kind of experimenting with angles and forces and trajectories.
Oh,
And all of those concepts are really important to
Mm.
understanding gravity.
yeah. That's a great way to make it relatable, Physics isn't just some theoretical thing in a textbook. It's like,
Right.
it's in the games we play.
Exactly. And the student feedback from the program really reflects that.
Oh, that's awesome.
They said things like, the simulation lets me figure out the concepts rather than just listening and believing what is taught without understanding.
Wow. That's impressive.
Yeah, they really are getting it.
Yeah, they're taking ownership of their learning
Yeah.
and not just memorizing facts.
Uh-huh.
That's
yeah.
really cool.
And another student even said that using the simulations made them feel like a scientist
Oh, wow.
because they were analyzing data, making predictions, drawing conclusions.
That's fantastic. It gives them a sense of agency,
Yeah.
they're actually doing science,
Listen.
not just reading about it. But was all the feedback positive? Were there any challenges or criticisms?
So some students did point out that
Yeah.
not all simulations are created equal.
Oh.
They felt like some of them were a little too simple
Oh,
and didn't really challenge them to think critically.
makes sense. So the design of the simulation really matters.
Yeah, it really
Like
does.
a bad simulation could actually be worse than no simulation.
Exactly. And that's where this aha moment came for the teachers in the program.
Okay.
They realized that they don't have to just rely on pre-made simulations.
Mm-hmm.
The training actually empowered them to become creators themselves.
Oh, wow. So they learned to build their own simulations with EJS.
Exactly.
That's incredible. That really addresses that problem of simulations being too simplistic.
Exactly. They could tailor them to
Mm.
their students' needs and interests.
Yeah. It's moving away from this one-size-fits-all approach
Totally.
and making it much more personalized
Right.
and engaging.
Exactly. And that's what I find so inspiring about this whole story.
Yeah,
It's a great example of how technology can really transform education,
it is.
not just by giving us new tools,
Mm.
but by actually fundamentally changing how we approach teaching and learning.
Right. And this 5E model, it seems like a key part of that shift.
Absolutely. So let's dig into that a little bit more.
Okay, I'm ready. Let's hear about how they actually integrated the 5Es into these simulation-based lessons.
Okay. So remember those 4 simulations we talked about?
Yeah?
The ones about geostationary orbits, 2 mass systems, the Earth-Moon system, and Kepler's laws.
Mm.
The training program showed teachers how to use each of those in a lesson plan that follows the 5E instructional strategy.
Okay, cool. Can we walk through an example?
Yeah. Let's take the Earth-Moon model
Okay.
and the concept of escape velocity.
Perfect.
So in the engage phase, the teacher might start by asking the students, like, what do you think it takes for a rocket to break free from Earth's gravity and travel to the moon?
That's a good question. Gets them thinking, right?
Yeah, it gets them thinking about the challenges involved.
Yeah.
It taps into their prior knowledge.
Yeah.
And it kind of sets the stage for the exploration that's going to come next.
Awesome. So then they get to play with the simulation.
Exactly. So in the explore phase, they actually get to use the Earth-Moon simulation.
Cool.
And they can experiment with adjusting the rocket's launch speed. And then they observe what happens. Does it escape Earth's gravity, or does it end up falling back down to Earth?
Oh, that's way more fun than just like, hearing a lecture about it.
Exactly. And as they're exploring,
Yeah.
they're probably going to start noticing patterns,
Hmm.
and they'll start to form their own hypotheses about what factors influence the escape velocity.
Makes sense. And that leads them to the explain phase.
Right. So in the explain phase,
Okay.
they would try to kind of articulate their understanding
Yeah.
of escape velocity
Yeah.
based on what they've seen in the simulation.
Got it.
They might discuss their findings with their classmates.
Okay.
They compare their results
Yeah.
and then try to come up with an explanation of how it all works.
That's cool. So they're really thinking it through. Like, why does this happen?
Exactly. And the teacher can guide this discussion
Yeah.
by asking questions and helping them connect their observations to the underlying physics.
Yeah, I like that. It's not just about getting the right answer. It's about really understanding it.
Right. And then that deeper understanding
Mm-hmm.
is reinforced in the elaborate phase.
Okay.
So here, the students could apply what they've learned
Yeah.
to new situations.
Okay.
So for example, they might explore
Mm-hmm.
how escape velocity changes depending on the mass of the planet
Oh, interesting.
or the mass of a star.
That's a good way to see how it applies in different places,
Sure.
like not just our own solar system.
Yeah, and then of course there's the final evaluate phase.
Right.
And this allows the teacher to assess their understanding
Okay.
of escape velocity.
So like a quiz or something.
Yeah, maybe a quiz, a presentation, or even like a creative project.
Oh, cool.
Yeah.
Like design a mission to Mars or something.
Exactly. So you can see how the 5E model really provides a structured framework
Yeah.
for creating engaging and effective lessons
Total.
using simulations.
It seems like a really versatile approach, too. You could use it for all kinds of physics concepts.
Exactly. And the training program actually provided the teachers
Yeah.
with a bunch of resources beyond just the simulations themselves.
Like what?
So they had a collection of worksheets, activity ideas,
Yeah.
assessment rubrics,
That's hopeful.
all designed for using EJS in the classroom.
Wow. So they weren't just left to figure it out on their own?
Right. They had a whole community
Wonderful.
of educators to learn from and to collaborate with.
That's awesome. Especially when you're trying something new.
Mm-hmm.
It's nice to have that support,
Totally.
But I'm curious about the challenges they face, too. We talked about some students finding the simulations too simple. How did the program address that?
Right. So they really emphasize the importance
Okay.
of carefully selecting and designing the simulations
Okay.
to make sure that they're meeting those learning objectives.
Yeah.
and that they're challenging the students at the right level.
So it's not just about using any old simulation. You got to pick the right one.
Exactly. And remember, the program
Yeah.
actually empowered the teachers to create their own simulations.
Right, I forgot about that.
So they weren't limited to using pre-made stuff.
Yeah.
They could tailor the simulations
Mm-hmm.
to their students' specific needs.
That's really cool. So they could make it as challenging as they needed to.
Right. And they could even incorporate elements of game design.
Oh, fun.
You know, drawing inspiration from games like Angry Birds
Yeah.
to make it more fun and interactive.
I like that. So they're kind of blurring the lines between learning and play.
Exactly.
That's really cool.
And the students even had suggestions
Oh, really?
for how to improve the simulations.
Like what?
So one student suggested making the simulations more competitive,
Oh.
like maybe adding a scoring system
Okay.
or letting students race against each
Oh,
other
I like that.
to complete the challenges.
A little friendly competition.
Yeah, exactly.
Yeah, that could be really motivating.
And another student suggested adding more visual elements,
Oh, okay.
like graphs and charts, to
Yeah.
help them analyze data
Mm-hmm.
and see patterns.
Visuals are always helpful, I think.
Right. And it just highlights the fact that we need to provide different ways for students to engage with the material.
Yeah, totally. Not everyone learns the same way.
Exactly. And it
Yeah.
sounds like this program in Singapore really embraces that
Yeah.
by empowering teachers to customize those simulations
Yeah.
and to tailor their lessons
Mm.
to their students' needs.
Yeah. That's awesome. So it wasn't just about teaching them EJS.
Right.
It was about this bigger shift in
A
thinking.
human mindset shift.
Yeah, moving away from passive lectures
Yeah.
towards something much more active and engaging.
Exactly. And that kind of brings us back to our listener.
Right. Like, what can they take away from all of this?
Yeah. So it's important to remember that this program in Singapore,
Mm-hmm.
just one example
Yeah.
of how simulations are being used
Right.
to revolutionize education.
Yeah.
But the principles behind it,
Mm-hmm.
like active learning, engaging students, empowering teachers,
Yeah.
these are universal.
They are. Whether you're a teacher or a student or just someone who loves learning.
Exactly.
Yeah.
And you can apply these principles
Mm-hmm.
to your own life.
Yeah, absolutely.
So don't be afraid to experiment,
Yeah, try new things.
to explore different ways of learning,
Totally.
and to share what you've learned with other people.
That's what it's all about.
And if you're ever feeling stuck
Yeah.
or uninspired,
Mm-hmm.
just remember those physics teachers in Singapore
Yeah.
who embraced this challenge
Mhm.
of learning EJS
Yeah.
and transform their classrooms into interactive learning labs.
They're an inspiration. Shows what's possible
Yeah.
when we have the right technology and the right approach.
Totally. And so as we wrap up this deep dive,
Yeah.
we want to leave you with a challenge.
Okay, I like a challenge.
Think about your own field,
Mm-hmm.
your own interests, your own learning journey.
Yeah.
Where could simulations play a role?
Ooh, good question.
Could you use the simulation
Mm-hmm.
to learn a new skill,
Yeah.
to explore a concept,
Mm.
or to share your knowledge with other people?
Ooh, that's interesting.
So don't be afraid to be creative,
Yeah.
to experiment,
Mm-hmm.
and to kind of push the boundaries
Push the boundaries. I like that.
of what's possible.
Yeah, what's possible with simulations. It's a whole new world of learning.
Exactly. The future of learning is
Mhm.
interactive, engaging,
Mhm.
and personalized.
Yeah, and you, our listener,
Mm-hmm.
you have the power to help shape that future.
Exactly. Yeah, it really is amazing to think about all the possibilities.
It is,
I mean, if simulations can make physics more engaging,
right?
imagine what they could do for other
Oh,
subjects.
totally. Like history.
Oh, yeah.
You could have these interactive simulations of like
Yeah.
major historical events.
Mhm.
Students could explore ancient civilizations.
Right.
They could see battles unfold or even like step into the hues of a historical figure.
Oh, that'd be so cool.
Yeah.
What about biology?
Oh, biology's perfect for simulations.
Yeah.
You could dissect a virtual frog. Oh.
Explore the human body in 3D.
Wow.
You could even simulate like the spread of disease
Oh, wow.
to understand epidemiology.
And it's not just about engagement.
Right.
It's also about accessibility.
Totally.
Simulations can give opportunities
Hmm.
to students who might not have access to labs or
Indeed.
equipment for hands-on learning. It really levels the playing field.
It does.
Like everyone can participate,
Yeah.
no matter what their background is or what resources they have.
And think about personalized learning.
Oh, yeah.
Simulations can be adapted
Well,
to
yeah.
different learning styles.
Yeah, different paces.
Mhm.
Students can go at their own speed
Mm-hmm.
and focus on the areas where they need more help.
It's almost like having a personal tutor.
Yeah, it is.
right there built into the
It
experience.
feels in.
And they can get immediate feedback. They can retry things
Yeah.
as many times as they need
As many times as they need.
and really explore concepts
Yeah.
at a depth that you just can't do
Right.
in a traditional classroom.
That's the power of simulations.
It is.
It's changing education.
Mm-hmm.
It's going beyond passive learning.
Yeah.
Empowering students
Right.
to be active explorers, to be critical thinkers.
It's about fostering that love of learning,
Yeah.
that goes beyond just memorizing for a test.
Right. It's about inspiring them
Yeah.
to question, to
Good.
experiment,
To discover.
to discover,
Exactly.
and to equip teachers
Yeah.
with what they need to create these experiences.
That's what that program in Singapore did.
It did.
That's what it showed us is possible.
Yeah. So as we wrap up this deep dive,
Okay.
we want to leave you with a challenge.
All right. I'm ready.
Think about your own field,
Okay.
your own interests,
Mm-hmm.
your own learning journey.
Right.
Where could simulations play a role?
Ooh.
Could you use a simulation to learn a new skill,
That's a good one.
to explore a complex concept,
Yeah.
or to share your knowledge?
With other people.
Oh, I like that.
Don't be afraid to be creative,
No, be creative.
to experiment,
Experiment.
to push the boundaries
Push those boundaries.
of what's possible.
Yeah.
The future of learning
Yeah.
is interactive,
It is.
it's engaging,
Mm-hmm.
and it's personalized.
It is. And you, our listener,
Right.
you can help shape that future.
That's it for this deep dive
Wow, what a deep dive.
into the world of gravity simulations
And the 5 E's. Don't forget the 5 E's.
and the 5E instructional strategy.
Awesome.
We hope you learned some new things
Yes,
and that you're feeling inspired
I am.
to explore the potential of simulations
Absolutely.
in education and beyond.
And beyond.
Until next time, keep diving.